Hello everyone. Welcome to the intermediate module of data structure and algorithm. I'm genuinely excited to begin this journey with all of you. As we move from the absolute basic to advanced problem solving, my goal is to keep this course highly interactive, structured, and impactful. To achieve that, we will follow a simple, powerful three-step framework every week. So step one is daily shorts and question. So to keep your momentum strong, I will be posting a daily conceptual question or a short video on YouTube and our community platform. This will help you to stay consistent and continuously engaged. Step 2 is Sunday live session. Every Sunday we will go live together. In this session we will solve top interview level problems and I will personally address all the doubts and question from the comments. Step 3 is the golden rule, consistency and practice. Teaching is my responsibility, but practice is yours. If you truly want to master DSA and crack top companies, you must stay consistent and actively practice everything we cover. Now, to support your learning, all lecture notes will be shared right after each class on our WhatsApp channel. In addition, I will also share my personal WhatsApp number with you. So if you ever feel stuck or need a guidance regarding placement, you can reach out to me directly. Remember, don't isolate yourself, ask questions, support each other, and let's build a strong engineering community together. At the end of the day, consistency is what we separates a beginner from a top engineer. So without wasting a single second, let's jump straight into our very first lecture, Introduction to Problem Solving, Part 1. So in Introduction to Problem Solving, we are covering these 7 topics: count the factors, optimization for count, check if number is prime or not, sum of n natural number, definition of AP and GP, number of iteration, and how to compare two algos. So first we will start with what is factors. I think everyone know what is factor. So if I is a factor of n, if I divides n completely. So we can say if n modulo I is equals to 0, then I is a factor of n. So now I will give you one small quiz. Okay, first check this quiz. Number of factors of the number 24. If you know the answer, please reply in the comment section. So meanwhile I will also write here. So the factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. So total numbers are 1, 2, 3, 4, 5, 6, 7, 8. So the answer is factor of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. Now I will give one more quiz. Number of factors of the number 10. If you know the answer, please update in the comment section. Yeah. So factor of 10s are 1, 2, 5, 10. Okay. So, okay, we will start from here. So, we calculate the factor of 24 and 10, right? So if you check properly, sorry. So we can say there are two observations. Okay. Observation one is all factors start with 1. So if you see 24 start with 1, 24 factors start with 1 basically, and 10 factors also start from 1, correct? And second observation is last factor always a number itself. So if you see 24, the last factor is always a 24 only. And same for 10, last number is 10, correct? And if you want to know how we calculate the factors, we just simply check one is when we can divide 1 or 24 with 1 or not, same 2, 3, 4, and all. So here for 24, the count is 8. and for 10 the count is 4, correct? And we have a two observation. First vector always 1, and second last vector always is n means the given number, correct? So this is our two observation basically. So to solve this, what we can do, we need to just check all the numbers from 1 to n if it is divisible, completely divisible or not. Completely divisible or not, correct? So I will write a function called count factors, simple function. Here you can see we initialize C to count the factors, and we start the for loop from I is equals to 1 to is equals to n till n, and if n modulo I is equals to 0, it means I is a factor of n, and we did plus plus C, correct? And we are increasing the count, and we at the end we are returning the count. Okay, but one more thing. So here you can see our code will run from 1 to n times, correct? So we can say this code will take n iteration. Means if the input is 24, then it will take 24 iteration. If the input is 10, or maybe if the input is 100, then it will take 100 iteration, correct? Okay. Now we will do one assumption, okay? We will do the an assumption. Assumption is uh like this code will run on a server, and my computer will take 10 to the power 8 iteration per second. Okay. It means 10 is to the power 8 iteration means 1 second. It means we can say one iteration is equals to 1 upon 10 is to the power 8 second, correct? And at the end we can say n iteration is equals to n upon 10 is to the power 8 second, correct? This is our observation, okay? Now I will take an input, okay? We will say n is equals to 10 is to the power 9, okay? So with this formula, we have n upon 10 is to the power 8 second, correct? So we will update the value of n with 10 is to the power 9. And if we divide, we got 10. So it means it will take 10 second, correct? Now we got an input as 10 is to the power 18. Okay. What we get? 10 is to the power 18. Now, for 10 is to the power 18, if we divide with 10 is to the power 8, we got output as 10 is to the power 10. And it will take something around 317 years. So tell me, would you able to see the output of the code? Maybe you, your children, maybe third or fourth generation will see the output, right? If it will take 317 years. So we can say there is a problem with this code, correct? Now, I think you understood, right, what I want to say, why it is taking 317 years or something. If you have any query, please add in the comment. I will check and I will reply you. Now, we will go with the different approach, okay? This is some different approach. And here, what happened? We can say if I into j is equals to n, for example, we have factor 24, or we have an input as 24. And if we want to check the factor 1 into 24 is equals to 24. It means 1 as a I. Okay, I will tell you in this way. For example, we got an input as 24 and 1 into 24. This one and this one means I and j is equals to n. So I and j both are factor of n, correct? Correct. So we can say j is equals to n upon I, and I comma n upon I are the factor of n, correct? So we got some observation like I and n upon I are the factors of n, correct? So we can say if I is a factor of n, then n upon I is also factor of n, correct? So let's take a same input 24. I make one table here. So here you can see I, and here you can see n upon I. And here we have the count as 0, correct? So here what you can see, first we take the factor. Like for example, we have factor 1. And if we divide n by I, means 24 by 1, we got 24. I is less than n upon I, correct? 1 is less than 24. So both are factors, right? 1 is also a factor and 24 is also a factor. So we will do C plus 2. C plus 2, why we are doing? Because 1 and 24 both are factor, correct? Same we will do for 2 and 2 and 12, right? Because 2 and 12 also a factor. Same 3 and 8, because 3 is, if we divide 24 by 3, we got 8. So 3 and 8 both are the factors, and 3 is less than 8. C is equals to 2, we will do, correct? And same here, 4 and 6. Okay, so this one done, and this one, these two are also done. So now next input is 4 and 6. Both are factors, so we can do C plus 2 something, correct? Now we will make a bridge here. If again we will check 6 and 4, like again if we got a factor 6 and we will divide 24 by 6, we got 4. So we already count 6 and 4, right? So it will be duplicate if we count again. So here we got a condition. What condition we got? If I is less than n upon I, like we need to calculate, we need to count till I is less than n upon I, correct? I is less than n upon I, correct? Okay. And these all values we no need to count because it's we got a greater sign. So maybe you can say we will start a loop and we will add a condition to add like I is less than n upon I, and we will count the we will add C plus 2 something, right? Now we will take one more example here before going to the coding. Oh yeah. So the next is n is equals to 100. Okay. So here you can say, one second please. We got an input as n is equals to 100, and here I is equals to 1. When I is 1, n upon I is 100. So here I is equals to I is less than 100, right? I is less than 100. One second, I will remove this equals to, otherwise you may be confused. Okay, so here same, we will come to 2, we will calculate n upon I, we got 50 something, blah blah blah. And same for same we got for 4 and 25 and 5 for 20. Now next is 10. So if we divide 100 by 10, we got 10, right? So then we need to add here is equals to. And one more thing we need to add here, we need to add C plus 1, because both side I and n divide n upon I both are same. So we will make one more observation. We will have one more observation. We need to add less than n is equals to, correct? 1 is less than 100, 1 is less than is equals to 100. So we will, we can say in short, we will create a loop and we will add a condition. If I is less than is equals to n upon I, then we will make a count. And second thing we will add, if I is equals to n upon I, then we will add just C plus 1, otherwise C plus 2. Got it? Now we will have one more thing we will have here. So we will iterate till I is less than n upon I. Then we have I into I less than is equals to I under root, I is less than under root. Then we have here, like we can say we will like iterate till 1, 2, 3, 4 to under root of n, correct? So now we can say last time we calculate, right? 10 is to the power 18. So now if you calculate 10, under root 10 is to the power iteration, we got output as 10 is to the power 9 iteration, correct? If 10 is to the power 8 iteration is 1 second, then 10 is to the power 9 iteration is 10 seconds. So earlier we are solving that question or maybe problem in 300 or some 317 years, and now we are able to solve it in 10 seconds. Got it? So this is the code for that. So here you can see we have int count factor. So here we will create a integer like variable count. We will add the count of factors, and we will maybe run a for loop from 1 to under root of n. Here you can also write in this way. Okay, this is correct, but we can also write I into I is less than is equals to n. Okay, this is a little bit simple and you maybe remember. And after that, we will add a condition. If n percentile n modulo I is equals to 0, then it means I is a factor of n and n upon I. So you remember we decided if I is equals to n upon I, if both I and n upon I is same, we have an example 10, 1, right? When we divide 100 by 10, so we will increase the count with 1 only, and otherwise we will count with 2. So now at the end we will return the count, correct? So this is for the count of factors. Now second thing is prime numbers. But before this, if you have any query, please post in the comment section. I will quickly check and reply you. Maybe you can also use our WhatsApp community channel. You can post there also. So next is prime number. Okay. I think everyone know what is prime number. We can say number divisible by one itself, one and itself is prime number and has exactly two factors is a prime number, correct? I think these two definition we always saw, maybe we will saw in first, second class, or maybe from the beginning, we always see these two things, okay? But now one thing, for example, one is a prime number, right? If user pass n is equals to 1, which is a prime number. Okay, so if user pass here n is equals to 1, which is not a prime number, correct? But it will pass this condition number divisible by 1 and itself. So the first condition is wrong, correct? So we can say we have only one condition has exactly two factors. So if we have only one condition has exactly two factors, recently we completed one thing, that factor one. We just need to calculate the factor. If factor is equals to 2, then it means it's a prime number. Otherwise, it is not a prime number. Before that, we will give you one quiz. Please answer it in the comment section if you know the answer. How many prime numbers are there? 10, 11, 23, 2, 25, 27, and 31. Okay, so I'll tell you. If you see 10, we have a we can say we have a factors of 10 like 1, 2, 5, and 10. 4 factors we have. So this is not a prime number. 11. 11, we have factor as 1 and 11. So we have two factors. This is a prime number. Now second, the next one is 23. Same for 23, we have two factors, 1 and 23. So we have, can say this is a prime number. Same for 2, 1. So factor of 2 is 1 and 2. So this is also a prime number. Now 25. Factor of 25 is maybe more than 2, right? We can say 1, then 5, then it's a 25 also. So it is not a prime number. Now next is 27. 27, we can say 1, then 3, then 9, then 27 also. So this is also not a prime number. And the last is 31. 31 factors are 1 and 31. So this is a prime number. So we can say 4 is the correct answer, correct? And these all the 11, 23, 2 and 31 is a prime number. So now only we discuss how we can find the prime number. We will just add one condition to check the count factors with the given value n. If the count factor is 2, if the count factor is 2, it means it is a prime number. If the count factor is maybe greater than 2 or maybe less than 2, it is not a prime number. Simple. So that's all we are covering as part of this class. Maybe we will cover iteration and we can say geometric GP, AP. We will cover in the next video. Okay, thank you so much. Please share your feedback